How's it going, everybody? Thanks for stopping by, and let's dive into our next topic, which is going to be an overview of the modular policy framework on the ASA. Now, as we dive into this, we're going to be taking a look at basically some of the things that the MPF does, how it works, and some stuff like that. And we're going to need to understand pretty much how it operates and all that good stuff that goes along with it. So let's go ahead and I'm going to bust out my pen tool here as we are going to be doing some whiteboarding. So the MPF itself is designed to allow for advanced inspection. So an example of this would be you can do layer 3 and layer 4 inspection. So layer 3 and layer 4 is going to be basically IP transport and port filtering. So I can say, okay, I want to break down and filter based off of the source and destination IP or subnet, a particular transport like TCP or UDP, and I can say if the traffic is going from point A to point B using TCP, I wanted to permit telnet but deny web. So you can do things like that. And then when we talk about the operation, this is inspection, okay, actually looking at the traffic. Now, when we're doing this, this is typically tied to things in the global policy. So when we talk about this, we need to understand how the global policy is actually built. So the global policy is built off of a class map. So the class map is going to be the matching statement, and it is going to match on a number of different variables. There's the class map, it matches on something, but this is just a generic layer 3, layer 4 match. There's also the class map that inspects, which we'll be talking about when we get to layer 3 layer 7 inspection. Which, as a side note, if you decide to go the inspect route to where you want to inspect the application of traffic. So like for instance, you're not going to be happy with just simply inspecting HTTP communication. You want to dive in to look at the URL, and you want to say any traffic that's going to a specific URL on the internet is denied, but everything else is permitted. So you'd actually be looking at some field in the HTTP header that would allow you to look and say, okay, well, this is going to this destination, so I want to drop it. Or I want to permit this and not permit that. Now, the inspect class map is going to be layer 7 inspection. So you're going to be looking at something inside of the payload of the application itself. This is what they refer to as deep packet inspection. And we'll be taking a look at that for things like HTTP and DNS. Then we have the policy map. This is where you do the action. Now, the action itself can be anything. It could be, there's a number of things that it can do. And when we talk about this, we'll actually dive on the command line and stuff like that and break it down. There's also the policy map of inspect. Now, the policy map of inspect, again, is deep packet inspection. But here is where the deep packet inspection is actually happening at the class map level. And then the policy map goes through and takes that information and it says, you know what, that's great, that's awesome, but now I need to do something about whatever it is that I'm matching on. Whether this is a permit, a deny, or some other variable. So there's a lot of different things you can do with the traffic. And if it's permitted, then the traffic will obviously be allowed to pass through. If it's denied, obviously the traffic will be dropped and stuff like that. Now, when it comes to the class map inspect and the policy map inspect, you call the class map from the policy map, but you can't actually apply the policy map type of inspect to any interface because it's layer 7 inspection. When you're going to do this, you actually have to go through and map this directly to a layer 3 or layer 4 class or policy, and then you can go through and go from there, and then map it. Because then you're saying, okay, I want to match on any traffic But then I also want to take it a step further and look at any of the payload in that traffic. So you're looking at multiple variables. That's as far as I'm going to go right now when it comes to layer 7 inspection, because I don't want to just focus on that. When we're talking about the inspection we're going to do, some of the inspection that we've already taken a look at, which wasn't already enabled, like ICMP. So when we wanted to send pings through the firewall, we couldn't, right? Because they were being dropped and denied and all that other good stuff. Well, in cases where you want to allow this to go through, you could go underneath the global policy map, underneath the class of inspection default, and say inspect ICMP. And then all of a sudden ICMP would be inspected and you'd be allowed to pass through. There's also another one that I was actually surprised on was HTTP is not inspected out of the gate. But TCP and UDP are. But HTTP is a TCP application. So I was like, well, why is that not inspected? And then I looked into it. It's an advanced inspection option. Then you can go and say, you know what? I'm going to a specific URL, or there's a specific variable that you want to match on. So when we talk about going into the basics of advanced application inspection, there's kind of a tiered way of looking at this. We have basic inspection, which is going to include us turning on ICMP inspection or turning on HTTP inspection and simply keeping track of when HTTP communications go back and forth, things like that. Those are going to be the basic inspections. Now, you can tie them back to an ACL or other variable to be more specific as to who can talk to what, how they can talk to each other, that type of stuff. Or you can do advanced inspection, where the advanced inspection is going to leverage the inspect class maps and the policy map of inspect, and they are going to take it a step beyond that. So we're going to be focusing on this section right here for right now, even though every part of my being wants to go this way because this way is way more cool, but I have to tier it up. Now, when we talk about the class map is used to, again, match. Once we match on whatever it is we're trying to match on, then we can go through and use a policy map to call that class map so we can do something about whatever was matched on. And then we use a service policy to actually apply it. So now there's a multitude of things that we can do beyond this. So things like we can leverage, let me look at my notes. So out of the gate, you can do things like, where'd it go? Oh, here it is. That's why I couldn't find it. Let me do this. So the inspection, so the normal class maps, what they can do is things like, an example would be to do initial inspection. You can also set the connection limits. You can go through and adjust the TCP options. So we could say So connection limits being, you want to go and say you want to limit how many half open or embryonic connections there can be in a box. So you don't want to allow any embryonic. So if it's half open, or it's not, the three-way handshake hasn't completed completely, then you don't want to allow the traffic through at all. Stuff like that. Then when it comes down to TCP options, like I think a great example of this is if the ASA sits between two routers that are doing something like BGP authentication, and they're passing in MD5 hash between the TCP connection, if you don't allow that to happen, then the BGP authentication will never take place, the peering will never come up. Beyond that, you can dive into application inspection, which is what we talked about a little bit already. You can also dive in and you can redirect to the IPS. So I don't have it directly in front of me. I went out and I bought an ASA 5506, and I'm going to enable the Firepower Services module on it. And what that's going to allow me to do is take, and using the MPF, I could say, you know what, any traffic that comes in, I want to redirect that to the Firepower module, have the Firepower module inspect the traffic to see what's going on, and then return the traffic back down to the ASA, and then forward the traffic out if it's permitted or denied, depending on whatever policy I apply. So you can redirect it to an IPS. We can also leverage quality of service from this perspective, and we can say, you know what, we want to take a look at, you can do prioritization. You have, if I could type prioritization, which means, do I send certain types of traffic ahead of other types of traffic? Do I can also police outbound and shape. So police means you drop traffic when it exceeds a certain rate limit. Shape means you slow it down or queue it if it exceeds a certain limit. You can also redirect traffic for net flow. These are the several things that we dive into. We're going to be looking at all of them and how they come into play. The IPS one is going to be the more complicated one because I don't have an IPS sensor at the moment deployed. So that'll come. So this specific variation right here, the IPS, this will actually come in the 210, or the what I consider to be the that would be the threat control playlist. When I start recording videos for Firepower, so that'll include Firepower, the WSA, the ESA, and I think Cloud Web Security, if I'm not mistaken. So we'll be covering those topics in that section where that'll come into play, and I'll actually have the ASA fired up and ready to go, and it'll have a Windows VM or something sitting behind it that we can log into and then test connectivity through and stuff like that. So we're going to be looking at talking about how basic inspection here works out of the gate. This is what we're going to be focusing on first and foremost, because we need to understand how that works and operates. And we've already taken a look at some of this stuff. Then we're going to dive into connection limits. Then we're going to be taking a look at TCP options. Then we'll dive into application inspection. Then we'll be taking a look at QoS prioritization, policing, and shaping. Then we'll be taking a look at net flow. Also included in here, and it just hit me again that I didn't cover this yet, is inside of all of this, we also have to deal with there's threat detection. Threat detection. We have botnet traffic filtering. We'll be talking about how that comes into play. And we have DNS security. So DNS actually falls underneath the application inspection, and we're going to be covering that there. But there's a specific topic on the blueprint for the 206 exam that specifically calls out DNS security, and if the the size of the payload goes above 512 bytes. We'll have to talk about that. So we're going to be covering all these things inside of this section, but we really need to understand what it is that the ASA is doing. So what we're going to focus on here out of the gate is going through and looking at how the different policies come into play. And I got a lot of stuff pre-configured. Some stuff is working, so I'm going to show you just some of the flows that come into play and how they work. So let's go ahead and pull up the ASA. And this is going to be ASA 1. We're going to be doing all this on. And one question I got in between videos was, once you're done with the MPF, what is your next step? Well, the MPF is going to include QoS, because that's how you apply it. There's also, after that, we have identity firewall. There is, we've already covered HA. We still have to do transparent firewall and then multiple context mode. So we still have quite a bit left to cover, but we are steadily making our way through it. So here we have ASA 1. We drop out of global config. So the way that this operates is you first have the class map. So let's go to global config and type in class map, and you have a name or a type inspect. If I type in type inspect, and if I specify something like HTTP, and I say match any variable, and I type in, let's say, test. I come under here, I can say match on something in the HTTP header. So I'll say I match on request, and in the request I say in the header I want to match on, you know, a regex value or something in the host field, something that gives me something I can match on. And this is where the deep packet inspection comes into play. Let me go ahead and exit out. So the class map of here, I can just type in test, and underneath here I would say match, and what am I going to match on? Oh, I goofed up. Class map of underneath here we're going to say match, and we have a number of things that we can match on. So an example of this would be we can call an access list to match on, or we can call on any packets. So we can say, you know what, I don't care what the traffic is, I just want to match it. And this is typically the direction you're going to go when you want to do layer 7 inspection. If you're not tying that to a specific, if you're not trying to be super granular. And so what I mean by that is, when we get to application level inspection, and let's say we're matching, we want to block a URL. We're blocking a URL, and then we dive in, we want to tie this to a non-inspect class map, and we want to say, okay, well, we only want to restrict access to that URL from a specific host. So we have to create an ACL that allows TCP communication, but denies it from a specific source to any destination. And the logic gets it can get kind of confusing if you don't understand the flow. And that's why we're starting off with the flow here. So I can match off of the default inspection traffic, anything that's inside of that. If we've got QoS, the DSCP value, the flow if we're dealing with NetFlow, we have the port, precedence, RTP if you're dealing with voice over IP, and then tunnel group if we're dealing with a VPN. So then we have the policy map of either type inspect, or we have the regular one. So we'll just type in test, and underneath here we can type in, we'd have to say class, and whatever the class is. So we'll type in test, and then underneath here we can say, okay, based off of what we matched in class map of test, what do we want to do when traffic is matched on that? So we could come in here and say we want to police it. Police the output to, let's say, 100 megabits per second. So 1, 2, 3, 4, 5, 6, 7, 8. So that'd be 100 megabits per second, and we say if it goes above a certain rate, we're going to go ahead and drop the traffic. So we're going to say that, and then we can say, well, actually the conform action. Conform action would be to transmit, and the exceed action would be to drop. But if we were to say transmit, there should be a, okay, so it does the exceed action. So there's a, we can set the burst rate to that as well, but that's more specific to QoS. So it really doesn't matter what we apply, but if we do a show run class map test, right now we're not matching on anything. So let's go back to this guy and say, let's match on class map test. Actually, let's exit out here. Let's say class map test, and we'll say match any traffic. And then we come back here, we type in show run policy map of test. Underneath here, we're matching the policy map of, we've configured the policy map of test. We're calling the class map of test, which matches on any type of traffic. And we're saying, please the output rate to 100 megabits per second. So this is one of those things where you would say, okay, now that I've matched on any type of traffic, I have set the calling the class, so I'm saying I want to match on the specific traffic, which is anything in this case. Then I want to set the output rate that traffic can leverage to 100 megabits per second. If that's how fast my interface can send at, then that's as fast as I can go. And then what I would do is I would type in a service policy, and I would say test, and I would say interface outside, and hit the enter key. Now that's applied that variable to that. Now if I do a show service policy interface outside, and I say police, let's see, police show run service policy. Oh, it didn't. Show run policy map. Oh, okay, so that's part of the problem. So let me go do this. We'll say interface outside. Okay, here we go. So nothing, we haven't done anything with it. And if we were to say police, because that's what it's configured to do, I must have may have something backwards here. But an example of that's how you would do the class map and the policy map. A better example, if we were to do a show run policy map and say, hit the enter key. Let me come down here to this guy. If we look in here and we go to do the show run, and we say this guy, show run, oh, we have this variable right here. So we have the inspection default, which is matching on these, this by default. So we don't have any HTTP inspection. ICMP inspection is not enabled by default, so we have to add that. But you'll see that FTP, H323, IP options, NetBIOS, Remote Shell, RTSP, Skinny, ESMTP, SQL, SunRPC, FTP, or TFTP, SIP. All these applications are being inspected out of the gate, and they're being permitted, which means that they're just going to be inspected, and there's not going to be anything done to them if there's a match. They're just inspected. Now, one of the things that, when you're looking at this, I have gone through and I've added some capabilities to the class-default, which is normally not enabled. All this stuff is stuff that I've added here. And I said, okay, I want you to do, I've modified the connection table so that I want to define how, on a per client and client connections in general, how that traffic is handled. And if an application isn't doing a whole lot, keep it open even though the session might not be closed out, even though that it's exceeded its timeout. Let's allow the MD5 hash to come through in a BGP peering, and I want the ASA to show up in a trace route. We're going to talk about these more in detail as we go through. I'm actually going to delete every policy map that I've created in class map, and I'm going to rebuild it with you guys live on the command line, because I've tested all this stuff out. I know it works, I know it doesn't work, I know the flow logic that I need to follow, and these are some of the variables that come into play with how this all comes out. So now that we have that understanding, at the end of the day, if I wanted to add some sort of really, really basic inspection, the way that I would do this, let's say I want to inspect HTTP traffic. I would have to come in here to this level and right click and say inspect HTTP. Now if I just hit the enter key, it's just going to inspect HTTP. But if I hit the question mark, I have the ability of mapping a policy map to this inspection rule. So the inspection rule at the very basic is just saying match on any type of HTTP communication. That's what it's saying. Now if I map a policy map to that, that policy map might have a bunch of things that it's going to match on. Like I want to allow this, but I want to set the set variables here and set variables there inside of the HTTP header. One thing to point out here is all of this is clear text. I've tested it with HTTPS and I did not get good results. Matter of fact, most of the results actually failed the inspection. I had to go find clear text websites that were publicly accessible for me to test this out. And it worked once I did that. And I got lots of really good results. But this is one of those things that comes into play. So if I wanted to do layer 7 inspection, this policy map would be a layer 7 inspection. So it would there would be a class map of type inspect that would be calling some sort of matching statement. Then that class map type inspect would get called from a policy map of type inspect to do something on whatever traffic was matched. That policy map name would get added right here. And then that's how I would be able to apply anything that's happening at the application level or the deep packet inspection piece. Because there's actually two pieces that we need to understand here, and it didn't really hit me until just recently that deep packet inspection and application layer inspection are two different things. So the inspect HTTP is inspecting the application. So it's going to look for TCP flows going to port 80, HTTP. If I want to take that deeper and dive into the application itself, so I want to look at how the application operates. So a deep packet inspection, I have to take that a step further and include an inspection policy that does that for me. If I don't do that, then I'm simply doing layer 4 interpretation. And layer 4 interpretation is saying, okay, if the flow is TCP based and it's going to the destination port of 80, I know it's HTTP because that's the well-known port for HTTP. That's how you would correlate that. Now, if I was just to type this in and do a show run of this policy, now I'm inspecting HTTP, right? So HTTP is inspected now. So if I was to go to my, if I do a show service policy, the policy is globally assigned, global, and I type in inspect, and I type in HTTP, I'm now going to have a way of breaking down and saying, okay, what have I inspected? Now if I just type in global, it's going to show me all of this. It's a lot of output to try to go through and figure out what's happening. But if you want to go through and be specific as to what you just inspected, you can hit the enter key and it's going to drop down to that specific inspection policy. So an example of that would be, let's go ahead and pull up server 2. Server 2 has, I'm just going to open up a new web page to google.com. So now as it's going out and doing that google.com lookup, there's multiple things that are happening behind the scenes like DNS and other things. I'm going to go ahead and click back over here in the command line. I'm going to hit the up arrow and you'll notice that nothing is actually hitting it. Kind of weird, huh? So if we look back at here and we say, okay, well, why is that not working? Well, let's go ahead and close this guy out and open up this connection again. So let's give it a couple seconds for it to load, and then we'll type in let's type in msn.com. Okay, now it's trying to go out. This is a new connection. And there we have packets hitting it finally. So that's what I think it was. It was just the web browser. That's one thing I found when I was playing around with this stuff is if you just refreshed the screen with a new web page, anything that was already existing connection-wise wouldn't have any effect. Now if we look here, now we're at 129 packets. And going on. Well, but all we're doing is matching on HTTP. It actually does nothing because all we're doing is matching on it. So if we do the show run, let's actually go up here a little bit. If we do a show run global policy and we're doing any of this stuff, it's just matching the traffic. That is it. It's saying, okay, do I see HTTP? Yes, I do. Am I going to allow it through? Yes, I am. And away you go. There's nothing advanced here other than what I've done. Same thing with ICMP. ICMP will allow the communication through, but it isn't like ICMP could be permitted with an access list if you wanted to. But logically what's happening, if ICMP is not inspected, it won't be passed. But because ICMP and TCP are two different transports, you have to take into consideration that when I'm talking about web pages and stuff like that, I can still reach a web page or do a DNS query. That stuff is going to be allowed to go through because it's TCP and UDP. Same thing with DHCP. It's going to be allowed to go through. The reason why it's going to be allowed to go through is simple. It's communication that is inspected by default and cannot be turned off. That is the main driver here. Now that we have that squared away, I can go and look at this again. Now I have 269 packets have been inspected, and guess what pulls up? I have msn.com pulled up. Now, if I wanted to dive into more advanced configurations, I could. But this is basically, would I consider this to be deep packet inspection? No. Would I consider this to be layer 3 and layer 4 inspection? Absolutely. Because I'm not trying to do anything beyond looking at, if I do a show connection long, I have multiple TCP sessions opened up to the outside, right? And that's pretty much what this boils down to. I have all this stuff opened up to the internet, and this is what's happening. So they know, based off of what's going on, that this is a 443 connection to TCP. Oh, it must be a secure website. So you can deduce very, very easily, based off the layer 3 and layer 4 information, what's happening. More specifically, the layer 4 information. This is not deep packet inspection. This is simply application recognition of HTTP. That is it. Now, if I wanted to go deeper, I'd have to go in and create policies in order to do that. So this is basically how this would come into play. Now, I can also do this a little bit different. I can say, I can come in here, let's say this. I wanted to not inspect. Say class HTTP. No, sorry. That is here. So I've turned off HTTP inspection, right? So now I can go and let's say I wanted to take advantage of inspecting HTTP. So I could do this. I could say I want to create an access list called HTTP connections, and I'll say extended, and then I want to say permit TCP from any source to any destination equal to 80. Actually, let me do this. Let me create an object group, an object net or service. Actually, let me do this. Object group, and we're just going to say service, and we're going to call this HTTP. And then underneath here, we're going to type in the service object will be, no, that's not what I want to do. I want to do show run object service, show run object dash group. Oh yeah, here we go. This is what I want. So we're going to say object dash group service. So we're going to say HTTP and TCP. That's right. And then an object group with the same. Okay, so let me go to here and pull out web and HTTPS out of this group. So let's go underneath this group right here and type in no this guy right here and no on this one right here, because I want to match just on web communication itself. So I'm going to come in here and type in this guy, an object group with the same ID, but with different type exists. That's just weird. Let's say HTTP flows and TCP. Okay, that's better. So we're going to say port object equal to dub and HTTPS. So now what I get to go do is access list. What I do is show run access list, and I can map it. Access list. Do I have anything applied inbound? I do. So we'll type in no show run access group. No this. So we type in access list, and we'll say HTTP extended permit TCP from any source or any destination equal to, or I should say, it'll be object dash group, and we'll type in the object that we just typed in was HTTP flows. So that'll match on web and secure web. So now what I get to go do is I get to create a class map. So class map of HTTP. Underneath here, I'll get to type in match. In this case here, it'd be access list, and the access list name is HTTP. Multiple match commands are not supported. Okay. So that's kind of funny. Okay, so what I will do is show run access list. No access list. It'd be easier just to blow it away and pull this out. Equal to 80, and then we'll type in class map of HTTP. We'll say match access list of HTTP. Match commands are not supported except for multiple. Show run class map HTTP. Okay, so it's okay. There we go. So it actually is matching on what I want it to match on. And that's right. I don't have to match on an access list if I don't want to. But in this case here, I'm saying if the destination port is equal to it'll allow it to go through. So I can come in here and type in show run policy map Policy map, do I have an HTTP one that's specifically calling class HTTP? I am. Policy map. I don't see one. So we can go create an HTTP policy map of HTTP. We're going to type in policy map of HTTP. And underneath here, we're going to say class is HTTP. And underneath here, we're going to just inspect the traffic. So nothing more than that. Inspect HTTP. That's it. And then what we get to go do is we have a policy map now. So now we can type in service policy and type in, we have HTTP. We can type in service policy HTTP interface DMZ VLAN 30 and hit the enter key. So now if we do a show service policy of interface DMZ VLAN 30 of inspect and say HTTP, all we're doing the exact same thing we did at the global policy, but we have created an interface level policy as well. So now if I go back to this guy and I open up a web page to, let's say we go to yahoo.com. We hit the yahoo.com. It's trying to look it up. We come up here and we hit the up arrow, and as soon as it tries to reach out, it's transferring data. You'll notice that the traffic is actually, it doesn't look like it's, oh there, okay, there, it's finally inspecting the traffic. So what it's actually matching on is it's matching on HTTP flows, not HTTPS flows. So if I was to go to, like for instance, let me do a show run service policy. Okay, so I should be okay to do this. Let's type in blogspot.com. So this should open up. This is a clear text website out of the gate. So it finds it. So I should be able to hit the up arrow. And I see 159 packets getting hit. This is simply HTTP inspection. Simply HTTP. There's no HTTPS inspection at all. And as you can tell, it's coming in as HTTP. There's no details that's telling us otherwise. And if we continue to, as more packets come along, you're going to see more hits. So this is how you're able to go to the interface, or I'm sorry, you're able to look at the global policy, and you're also look at the interface level. So let's go ahead and kind of look at what we did. Let's do a show history and take a look at what we actually accomplished. So let me grab all this. Right here. Let's go ahead and pull this up in Notepad and break down what we covered. So let's go ahead and remove some of this stuff. All right, so what we did, and there's a class map called HTTP, and it says match TCP port equal to 80. That's what that command is basically saying. So we're saying I want to match on web traffic, and I want to say that, or we could have said match anything for that matter. Underneath the policy map of HTTP, we say call the class HTTP. So this class right here is calling this line right here. Then we say inspect the traffic as it's coming through. And then we are going through and we have the service policy applied. So this is how you actually enforce this. And if we look right here and hit the up arrow, we see that traffic, 1,200 packets have gone through in order for this to work. Now let's say if I go to I have this page here. If I go back to MSN, and which is an encrypted path, if I resynchronize this, it's going out and it's forming a TLS connection. I come back up here and hit the up arrow. It actually is incrementing. So when you're dealing with just normal HTTP inspection, it's going to detect that and be able to forward the traffic. Even though my port only specifies port 80, there's got to be some communication that's going outbound that is port 80. So if we do let's do a show con long pipe include 80. Let's see, let's go through here. Oh, actually, I should say that's actually a bad example. Let's do /80. So there are a couple of flows. Let's come down here a little bit. There are a couple of flows coming from my PC, so 172.16.30.10, 4 specifically, that are going to port 80. That is why we see packets keep incrementing. That's why we see what we're seeing. So if you can look at the log and go and correlate, if there's nothing showing up here, that'd be a different story. But in this case here, there's a number of flows going outbound that are matching on that particular packet or that port and stuff like that in the transport. That's how this comes into play. And again, this is basic inspection. So if we look at the show run policy map, and we come down here to the bottom of the global policy, notice how ICMP is inspected. If we were to pull ICMP out, we wouldn't be able to ping. So that's basically how this comes into play. So this was an introductory video with a basic example. What we're going to be doing as we progress through this section is to dive deeper into this. So like if I wanted to, this is layer 3, layer 4 information that we're taking a look at and allowing the communication to pass through. If I wanted to go deeper, I could. So I'm actually going to unconfigure all of this. All the class maps are going to go away, and if you're curious to see how that would work, we're going to say clear configure service policy and hit the enter key. And we're going to say clear configure policy map and clear configure class map. So let's do a show run policy or class map. Nothing's there. Policy map. Nothing's there. Service policy. Nothing's there. So now we do a show run policy map. Did that get rid of the default one? Oh, I did get rid of the regex as well. It got rid of the globally configured one as well. Okay, not a problem. We can fix that pretty easily. We're going to go to ASA 3. We'll do a show run policy map, and we'll take all the way up to this, because these are the defaults. So it's going to go to global config, and we'll just paste this back in. You know what I can do? Let's do so it says class map inspection default not configured. So let's say show run class map. Let's do this. And then we'll say, do this again. Okay, that one got done. There we go. All right, so there we have that. So now if we do a show run policy map, There we go. So now, when we get into the next, now that also wants me to make, I want to test out real quick. Can I, blogspot.com, okay, that, so one of my inspection policies must have caught that. So let's come up here, and I'm going to go ahead and this is, let's say command prompt, and I'm going to go ahead and I want to ping 8.8.8.8. So ping is not working. So let's actually come up here and do an extended ping. Okay, extended ping is going. Let me go ahead and come over here to this guy, and we're going to go policy map, global policy, class, inspection default, inspect, copy and paste all that in, type in ICMP. Now after a moment or two, the ping should begin to work, because then it'll start to be inspected and start to operate. I might have to exit out of the policy for it to apply. Show run NAT. NAT's working. Show run access list. Everything else should be operational. Show xlate. Definitely have an ICMP going out, but why is it not coming back in? Ping google.com. See, it's able to resolve it, which means it's actually able to go out there and find it, but why is it not? Let me try to do it this way. Let me go from test9 ping 172.16.30.10. Huh. That's crazy. Show service policy, global, inspect ICMP. That is not that's not an inspection that I can look at. Inspect. Okay, I can't look at that. Global. Even though I've defined it. So service. Oh, hold on a minute. Show run. I think that's part of my problem. That's okay. So show run service policy. I know why it's not working. This is why. It didn't get applied globally. That's the problem is. So now, hit the up arrow. That'll work. So now, it wasn't being, just because it was being matched on doesn't mean it wasn't working. So let's go here and do show service policy, global, inspect. ICMP is still not showing up here. No big deal that it's not, but now if we look through here, we look down and all the way at the bottom here, we see 38 packets are being inspected. Now we can dive into other things like going back to test 9, hitting the up arrow, and the ping works just fine. So that's basically how this comes into play. So could I remove the global policy and then do whatever I want at the interface level? Sure, I could do that as well. But as we go through here, we're going to be looking at other variations of this and stuff like that. So what we've covered so far is we've covered the class map and how it works, and then we looked at applying it at the interface level, and then also the global level. So everything that I configured up to this point is now gone. So it's going to be a matter of us going through the process of reconfiguring everything and having to build it back up and stuff like that. So we're going to be covering a lot of stuff in the near future. So that's pretty much where we're at. There's going to be a lot of stuff that we're going to be diving into. So until next time, guys, thanks so much for stopping by, and we'll catch you in the next one.